Okay, physics people, we're going to talk about right triangle trig. Why are we going to talk about right triangle trig? Because right triangle trig is used in determining the direction of vectors quite often. So, right triangle trig implies that we need a right triangle. Take a look at these two triangles. Here we got triangle 1, here we got triangle 2. One of them is a right triangle and one of them is not. One of them is obviously not. Which one is the right triangle? Well, if you selected triangle 1, you would be correct because there's the right angle. Triangle 2, the green one, cannot be used in right triangle trig because, you guessed it, it's not a right triangle. You gotta have a right triangle. Now, when we employ the techniques of right triangle trig, we use something called SOHCAHTOA. It spells kind of like it sounds, but it's important to spell it right. SOHCAHTOA. How's that look? Well, this is the way I like to write SOHCAHTOA. You can see we got the so part, there's the ka part, and there's the toa part. Now, it's been said that this stands for, well, I told you in class, but actually mathematicians and us physics types, we use it, the S standing for sine, the C standing for cosine, and the T standing for tangent. And there's an equal sign here. And there's an equal sign there, and then one down here. So it's the sine of what? Well, it's always the sine of some angle. So this sine, this cosine, and this tangent here, they're not just sine, cosine, and tangent alone. They're always of some angle. Now, what angle? Well, it depends on what we're talking about here. So I want to take a look at what the O's, the A's, and the H's are all about. Now, I know I didn't say it before, but if you haven't been writing this down and you're not an expert on it, start it over, start writing it down. So, what does O stand for? Well, O stands for opposite. What does H stand for? H stands for hypotenuse. What does A stand for? A stands for adjacent, which is a fancy word for next to. So let me draw your attention over here to this triangle that I have drawn. And let me ask you, what is the hypotenuse? There is definitely a definitive hypotenuse, and that would be this side that I'm labeling as H. How do I know? Well, the hypotenuse is the longest side in a right triangle, but the giveaway is the fact that I got a right angle down here. And so that right angle that I've marked there in red, that opposite the right angle is the hypotenuse. Now, which side is the opposite side? I wonder. That's actually almost a trick question because I can't tell you what the opposite side is until I tell you what angle I'm identifying. Remember, the sine, the cosine, the tangent are sine, cosine, and tangent of some angle. We generically call our angles in physics, because we're a little bit crazy, the Greek letter theta. That's kind of like the unknown for an angle. You know, unknown for lots of quantities in math is x. Well, unknown in physics for angles is theta. So let's say I pick this angle to be theta. What's opposite that angle? Well, opposite is across from it, and that's across from it. So we have our hypotenuse, we have our opposite. That leaves one and only one thing to be our adjacent. There's our adjacent side. Let's try a different looking or similar triangle, but a different angle. So here we are, we're back with our exact same triangle as before, but this time I'm going to say that my angle of investigation is that angle up there. Now, what is our hypotenuse? Well, since it's the same triangle, the hypotenuse is not changed. It's opposite the right angle. What now is our opposite side? Well, it's opposite that angle theta, and this is across from angle theta, so that's our opposite. That leaves our adjacent side to be right next to that angle theta right there, and that's our adjacent side. Now, what the heck do we do with this? Well, let me show you some examples, at least one, maybe two, and we'll figure out how we make use of this. Let's say you go outside the high school building. It's a 4-story building. That's this strange-looking object I've drawn here. And let's say you're located right about here on the ground. Okay, and you're pretty small compared to the building, so we'll assume you're right on the ground. And let's say you take some measurements and you measure the distance from the high school building to where you are, and you determine that to be, let's say, 20 meters away. And then you use a device which you aim to the top of the building right along a line that goes like this. And you measure the angle here to be 63 degrees, we'll call it. And that angle is our now known angle theta, but that's just an angle that's 63 degrees. We use the sextant. That's a device we can use to measure angles just by aiming it upward. So we have two pieces of data. We know the distance to the building that we're standing in front of is 20 meters, and the angle from where we stand to the top of the building is 63 degrees. And our objective here is to determine how high is the building. How high is the building? Now, we can't get up on top of the building and drop a tape measure down to figure that out, so we're going to make use of what we have. Did you recognize that we have a right triangle? You say, where's the right triangle? What are you talking about? Well, right there's the right angle. And between the blue side of the building and the two green sides I've drawn, we have a right triangle. And we're trying to then figure out how high the building is. So we're looking for this side right here. Now, identify your O's, H's, and A's. Where's the hypotenuse? I'm going to show it to you. Better pause the video, though, and decide for yourself. There's our hypotenuse. Which one's the opposite side? Well, what's opposite 63 degrees? There's our opposite side. And which one's our adjacent side? Our adjacent side is down here. That's that 20-meter side. So really what we're looking for, the question mark is on the opposite side. We're trying to figure out how tall is the building, or what is the opposite side. So what are we dealing with? Well, we want to find out O for opposite, and we also are given A for adjacent. And we know the angle. One more time. We're looking for this right here, the opposite side, but we're also given the adjacent side is 20 meters. Which of these trig functions, sine, cosine, or tangent, deals with O's and A's? Well, it's obviously this one here, the tangent function, deals with O's and A's. So how do we set this up? Well, we do what it says. It says T equals O over A, or spelled out, that's the tangent of our angle, which we know to be 63, is equal to opposite over adjacent. Now plug in what we actually know. We know that we're taking the tangent of 63 degrees, and that's equal to the opposite side, which we don't know but we want, over the adjacent side, which is 20 meters. So the rest is calculator and algebra. Basically, we have to multiply both sides by 20. So we say 20 times the tangent of 63 degrees. That's equal to the opposite side. And what does that give us? Use your calculator and find out. Did you do it? That comes out to 39.25 meters. So 39.25 meters is how high this building was. If you lost any part of that, watch it again. Let's do another different example. Okay, here's our new right triangle. Now I'm going to give you some information about this right triangle. I'm going to tell you the hypotenuse is 12 meters. And I'm going to tell you that one of the sides is 7 meters. And I'm going to ask you to figure out this angle right here. We don't know what it is, so right now we'll just call it theta. And I'll say, hey, what is that angle equal to? So you think, what am I going to do? Well, we have information on this side and this side. What are those sides? Relative to that angle theta, what are those sides? Can you identify the hypotenuse? It's opposite the right angle. So where is the hypotenuse? Do you see it? It's the 12-meter side. Can you identify the opposite side? It's opposite my angle theta that I'm looking at. This would be the opposite side. And that makes the remaining side, the 7-meter side, the adjacent side. So you can see I have information on the hypotenuse and the adjacent side. I have an A and I have an H information. What trig function deals with A's and H's? The cosine function. So let's use the cosine function. What does it say? It says the cosine of some angle is equal to adjacent over hypotenuse. I don't know what that angle is, so I'm just going to keep calling it theta. The adjacent side, according to my triangle, is 7 meters. And the hypotenuse, according to my triangle, is 12 meters. Grab your calculator. And what does 7 divided by 12 equal? Pause it, try it. To 2 decimals, 7 divided by 12 comes out to be 0.58. Now, what do we do so that we can get our angle that we're looking for, theta, by itself? Well, here's what we do. We undo the cosine. How do you undo cosine? Well, there's what we call inverse cosine. Looks like this. A lot of people, student-wise, call it cosine to the minus 1 power. So you take the inverse cosine of the left side, but what you do to one side of the equation, you have to do to the other. So you take the inverse cosine also of the other side. And after you do that, what do you get? Well, the inverse cosine of cosine just leaves you with theta by itself. And so at the end, we can say theta equals, what is the inverse cosine of 0.58? Try it on your calculator, and you'll find out what the angle theta equals. Now, remember, we did round that 0.58. So using that 0.58 and taking the inverse cosine of that, we get 54 point, rounding to the next decimal here, 6 degrees. That's how you find an angle. To summarize, to find an angle, which is what we just did in this last example, you have to take an inverse trig function at the end. If you go back to the first example, we knew the angle and we were looking for a side. In that case, we do not have to take the inverse trig function. Review that example again and see what we did. Okay, so now here is your homework. Due tomorrow. 2 examples. The first example, right over here. Okay, triangle. You have one side of 50 meters. I give you an angle of 20 degrees, and I'm asking you to find the question mark side. How many meters is that side? What's the length of that side? Second example, going on over here. I give you another right triangle. I give you the length of 2 sides, 22 meters and 18 meters. And I'm asking you to find the angle theta. That's that green question mark side right there. Write them both down. Pause it, right? Write them down. Draw them out. Turn in your answer in class tomorrow. It's your homework. It counts double. So make sure you do it right. That's it. Mr. Nale out.